Hi everyone, welcome back to our video lecture on Introduction to Numerical Analysis. In the previous video we were discussing about numerical integration and we have come across trapezoidal rule. Now today we are going to discuss two modifications of trapezoidal rule or two modifications of the general formula, that is Simpson 1/3 rule and Simpson's 3/8 rule. Now let us quickly recall what is general formula and what was the trapezoidal rule. The general formula of integration says that integral from a to b f of x dx will be nh times y naught plus n by 2 del y naught plus n to n minus 3 by 12 del square y naught and so on. In trapezoidal rule, we put n equal to 1 in the general formula and reduce the integral to each subinterval. That means in each subinterval we substitute or we fix a trapezium and find its area. And we got the answer as integral from a to b f of x dx as h by 2 y naught 2 times y1 plus y2 up to yn minus 1 plus yn. Recall that what we were doing in this case is we are taking each subinterval and trying to keep a trapezium, fit a trapezium inside that one. Now let us see what we will do in Simpson's 1/3 rule. In the general formula which we have already derived, we will replace n with 2 to obtain the Simpson's 1/3 rule. So the integral from a to b f of x dx nh y naught plus n by 2 del y naught plus n to n minus 3 by 12 del square y naught plus n minus 2 whole square by 24 del cube y naught and so on. In that formula, we'll replace n with 2. So what will happen is the interval length will be x0 to x2. Interval length x0 to x2, y dx will be n will be replaced with 2. So it will be 2h y naught 2 by 2, that is 1 times del y naught 2 times 4 minus 3 by 12 del square y naught, and higher terms will become 0 because we have only two values x0 and x2. Simplifying, we will get 2h y naught plus del y naught plus 1 by 6 del square y naught. Taking 6 as common, then outside it will become h by 3. The first term will be y naught. Del y naught, del square y naught, everything you can convert using y naught, substituting y1 and simplifying, we will get the integral from x0 to x2 y dx as h by 3 times y naught plus 4y1 plus y2. Now we will repeat this process with the next intervals, that is x2 to x4, x4 to x6 and so on up to xn minus 2 xn. So we will get h by 3 y naught plus 4 y1 plus y2, h by 3 y2 plus 4 y3 plus y4 and so on. Adding all these integrals, we will get Simpson's 1/3 rule as integral from a to b f of x dx, that is x0 to xn f of x dx is h by 3 y naught plus 4 times y1 plus y3 plus yn minus 1 plus 2 times y2 plus y4 plus etc. yn minus 2 plus yn. Let us try one particular problem. Evaluate integral from 0 to 1, 1 upon 1 plus x dx using Simpson's 1/3 rule. The first thing what we want to do is we want to divide the interval 0, 1 into equal subintervals. In Simpson's 1/3 rule, we should be little careful that the number of subdivisions should be suitable for applying Simpson's 1/3 rule. Here, the values are given as x0 0, x1 0.25, x2 0.5, x3 0.75, x4 1. That is, n should be an even number. Now let us see the table correspondingly to these values. So we have y0, y1, y2, y3 and y4. Applying in the formula, we will get integral from 0 to 1, 1 upon 1 plus x dx will be 0.25 by 3, 1 plus 4 times 0.8 plus 0.5714 plus 2 times 0.6667 plus 0.5. The answer will be 0.6933. You can calculate this integral yourself and calculate the error of this integral. Try these problems yourself. Now let us see how we will get Simpson's 3-8 rule from this one. So in this general formula, we will substitute n equal to 3. So all differences higher than the third order will vanish. In the first subinterval, that is x0 to x3, the integral will be 3h y0 plus 3 by 2 del y0 plus 3 by 4 del square y0 plus 1 by 8 del cube y0. Substituting all these values and taking the LCM, we will get integral from x0 to x3 y dx as 3h by 8 y0 plus 3y1 plus 3y2 plus y3. Now we want to repeat this process in each of the subintervals. That is x0 to x3 y dx will be 3h by 8 y0 plus 3y1 plus 3y2 plus y3. Next is x3 to x6 will be integral x3 to x6 y dx will be 3h by 8 y3 plus 3y4 plus 3y5 plus y6. Continuing like this, you will get the last one as xn minus 3 to xn y dx as 3h by 8 yn minus 3 plus 3yn minus 2 plus 3yn minus 1 plus yn. Adding all these things, you can see that y0 will be alone. 3h by 8 will be common, y0 will be alone, 3y1 will be alone, 3y2 will be alone, y3 plus y3 will become 2y3, 3y4, 3y5, y6 will become 2y6 in the summation. So the Simpson's 3-8 rule will give you integral from a to b f of x dx 3h by 8 y0 plus 3y1 plus 3y2 plus 2y3. If you remember how we added and how you get 2y3, you will be easily get the pattern. It will be 1, 3, 3, 2. Then again 3y4 plus 3y5 plus 2y6. So this will repeat and the last term will be yn. You try these two problems yourself. Here we should be careful in only one thing, the number of subintervals, that is the x0, x1, x2, xn. This n should be a multiple of 3. Then only we can do this process. Thank you.